when you're solving rational equations, what you want to do is make sure you have a common denominator. And then what you can do is cross off the denominator and just solve for x using the numerator. So here's an example. So if you have x over 5 equals 2 over 5, if these denominators are the same, that means that x has to be equal to 2. So with these, you always need to check to see your restrictions as well. So you don't want to end up with something like x equals 2, but then have a restriction with 2 in the denominator. So always check to see what your restrictions are at the end. So in order to get a common denominator, again, you're going to factor out both rational expressions. So this part factors into x plus 3, x minus 3. So in order to get a common denominator, I need to have both terms, I need to have both binomials, x plus 3 and x minus 3. So I'm going to multiply the left-hand side by x plus 3 over x plus 3. Now I have a common denominator. So my new equation where my numerators are x plus 3 equals 6x, subtract x, so 3 equals 5x, x equals 3/5. So now I'm going to check, is 3/5 possible? Right here, can x be 3/5? Yes, it can. So you could plug in, what you want to do is plug in 3/5 in for x and see if the left-hand side is equal to the right-hand side. And number 2, you want to make sure you have a common denominator here. So I'm missing a 5 over here, so I'm going to multiply the top by 5 and the bottom by 5. Now I'm going to have negative 4 equals 15. So does negative 4 equal 15? No, it's no solution. So there's no number for x that you could plug in and have that statement be true. And right here, look at your denominators. You have a 2x, a 5x, and a 2. So for all these monomials, 2, 5, and 2, 2, 5, and 2 all go into 10. So, and we have an x on these two expressions. So I'm going to want to make my denominator 10x. So to make my denominator 10x right here, I'm going to multiply the denominator and the numerator by 5. So it's going to be 5 over 10x minus, and I'm going to multiply the numerator and denominator by 2 over here to make it 10x. So it's going to be minus 4 over 10x equals, and I want to multiply this by 5 and this by 5 and an x, I need an x as well. So it's going to be equals 5x over 10x. So you have all your denominators the same. So you can cancel these out and now solve your numerator. So 5 minus 4 equals 5x. 1 equals 5x. X equals 1/5. So now what you want to do is you want to see if is 1/5 restricted? No, it's not. And then you need to plug in and check to see if 1/5 works for these. So I'll show a check. So it's 1 over 2 times 1/5 minus 2 over 5 times 1/5. And does this equal 1/2? So 1 divided by 2 times 1/5 is 1 over 2/5 minus 5 times 1/5 is just going to be 1, so it's just going to be minus 2 equals 1/2. So 1 divided by 5/2 is 1 times 5/2. So does 5/2 minus 2 equal 1/2? 5/2 is the same thing as 2 1/2. So 2 1/2 minus 2 equals 1/2. Yes, it checks. And then the next one, your common denominator, we need an x plus 1 over here. So you cannot just add 1 to the top and the bottom. You have to multiply by the factor of x plus 1. So think about, so a common mistake would be adding 1 just to get a common denominator. So if you had 5, 6, and you just said, oh, I'm just going to add 1 to the top and on the bottom, is that going to be the same fraction as 6 sevenths? No, 5, 6 is different than 6, 7, so you couldn't do it with variables either. So I need to multiply this numerator by x plus 1, x plus 1, and I need to multiply this times x, and then you need to multiply the right-hand side times x, x plus 1, over x, x plus 1. So now I can cancel all of these out, and I have 4, I'm going to write a little bit nicer, times x plus 1 minus 3x equals x times x plus 1. So now you have 4x plus 4 minus 3x equals x squared plus x. So this is just going to be, over this side it's going to be x plus 4 equals x squared minus x, x squared plus x. Subtract x from each side, so x squared equals 4, x equals plus or minus 2. So I need to check to see if positive and negative 2, if they both work. So first I'm going to check positive 2. So does 4 over positive 2 minus 3 over 2 plus 1 equal 1? Does 2 minus, this is going to be 3 over 3, which is 1, equal 1? Yup. So positive 2 works. Now I'm going to try negative 2. So does 4 over negative 2 minus 3 over negative 2 plus 1 equal 1? So this is going to give me negative 2, and 3 divided by negative 1 is negative 3, but I have this negative right here, so 2 minus negative 3 is equal to 1. That works as well. So my answer is positive and negative 2. Both of them work. And they're both within the restrictions of here. The restrictions are x can't be 0 and x can't be negative 1. And then down here, solve for r. So what you could do is you could multiply this side. There's two different ways. You could do it how we've been doing, get the same denominator. So I multiply this by L over L. This cancels out, so now I have LT equals 24 times the quantity R minus R. I don't really want to distribute because I can just divide by 24 right here. So I have LT equals uppercase R minus lowercase r, and then I'm going to add R. So uppercase R equals LT plus R is the answer. And then over here, last one, solve for x. Solve for x. Okay, so I could get my common denominator of x times h squared plus j squared, but if this is a 0 over here, I'm going to add this expression to each side. So then what I'm going to have is 1 over x equals m times h squared plus j squared. So to solve for x, I'm going to multiply both sides by x in order to get my x out of the denominator. So this is going to be 1 equals mx, that's my numerator, over h squared plus j squared. Then I'm going to multiply both sides by h squared plus j squared to get h squared plus j squared equals mx, and I'm going to divide both sides by m. So x is equal to h squared plus j squared over m. And I know it's probably, maybe you thought of it differently as getting a common denominator here and here and here, but you couldn't really get a common denominator with here because no matter what you multiply, if you multiply anything by 0, it's going to give you 0. That's why I added this to this side.